Okay, so what we're looking at today is something that by all rights probably shouldn't even exist. It's an ancient city of stars we call Caldwell 1, and it really should have been torn apart billions of years ago. The fact that it's still around is a fantastic cosmic puzzle.
You see, most star clusters are what astronomers call open clusters, and you can think of them like stellar families. They're all born together from the same cloud of gas, but they're not very tightly bound. So over time, just the gravitational hustle and bustle of the Milky Way galaxy tends to pull them apart. But Caldwell 1, it's totally different. It's an ancient open cluster that has just refused to break up. So what gives? What's its secret? How did this one cluster manage to survive for eons while so many others just faded away? Well, that's the mystery we're going to unravel today. To get started, we've got to do what any good detective would do. We're going to check the vitals. We need to build a profile of this thing, this anomaly, to really understand what we're dealing with. And boom, here is the first shocking number, just over 7 billion years old. Now, for an open cluster, that is just astonishingly ancient. I mean, it's way older than our own sun and has been around for more than half the age of the entire universe.
And look, this isn't just some wild guess. Scientists get to that number using tools just like this, a color magnitude diagram. Basically, by plotting the brightness and the color of thousands of stars inside the cluster, they can see exactly where those stars are in their life cycle. It's like a cosmic clock, and it tells us with amazing precision just how long this stellar family has been sticking together. So, to get our bearings, Caldwell 1 is hanging out about 6,000 light-years away from us in the constellation Cepheus. And because it's so close to the North Celestial Pole, if you're in the Northern Hemisphere, you can actually see it all year round. It never sets. Officially, yeah, it's one of the oldest open clusters we have ever found.
Okay, so now that we know what it is and how old it is, we can get to the really big question. How in the world did it manage to survive against all the odds?
Well, the answer seems to boil down to 3 key things. First, it's pretty massive for an open cluster, so its own gravity gives it a really good grip on all of its stars. Second, it's all about location, location, location. It lives way out in the quiet suburbs of the Milky Way, far away from the chaotic inner galaxy where gravitational forces would have just shredded it. And third, and this might be the most important part, it has a very, very special orbit that just keeps it out of trouble. And hey, don't just take my word for it. This isn't just some nice theory. As this quote from a 2005 study points out, its orbit is highly inclined. What that means is it spends most of its time traveling high above and way below the main crowded plane of our galaxy. It's like it takes a scenic bypass, avoiding the galactic rush hour traffic, and that has allowed it to survive for billions of years. But you know, an old, stable cluster like this is more than just a survivor. It's a whole city, a bustling metropolis, with a really fascinating population of stars inside. So, what kind of residents live in this ancient stellar neighborhood? To find out, astronomers launched this major investigation called the Pisces Project. The main goal was to go hunting for planets that might be orbiting the stars inside Caldwell 1. And you can see from the survey fields here, they took a really deep, focused look right at the heart of the cluster. And the results were fascinating, just not in the way they expected. They didn't find any confirmed planets, but what they did find was this treasure trove of other stuff, 18 variable stars nobody knew were there, and a confirmation that the cluster is absolutely jam-packed with binary star systems, pairs of stars locked in these amazing gravitational dances. And a lot of these are what's known as a spectroscopic binary. This is a system where 2 stars are orbiting each other so incredibly tightly, and they're so far away, that even our best telescopes can't split them into 2 separate points of light. We only know they're there because we can detect this little telltale wobble in their light as they orbit each other, moving towards us and then away from us. And this is what that wobble looks like when you plot it as data. See that repeating wave-like pattern? That is the dead giveaway, the signature of an unseen companion star pulling its partner back and forth. It's pretty cool. This is how astronomers get to eavesdrop on the secret dance of these incredibly close binary systems. So while they were studying all these systems in Caldwell 1, astronomers found one that it didn't make any sense. The data showed a wobble, for sure, but the pattern was just weird. It didn't fit the model for a simple 2-star system. Something else was definitely going on. And the solution was just incredible.
They realized they weren't looking at one binary system, they were looking at two binary systems, and both of those pairs were orbiting a common center of gravity. A star system with 4 stars. Finding a stable quadruple system like this is exceptionally rare, and it's just another clue that this ancient cluster is a truly wild and dynamic place.
All right, so we've got a 7 billion-year-old survivor that's full of all these strange star systems. It's fascinating for sure, but why does it actually matter? What can this one cluster really teach us about the universe? Well, it matters because Caldwell 1 is pretty much a perfect cosmic laboratory. You see, we have plenty of very young baby open clusters, and we have these really ancient, massive things called globular clusters. Caldwell 1 sits right in that sweet spot in the middle. It's a middle-aged collection of stars, all born at the same time, which gives us this unique snapshot of how stars, just like our sun, grow and evolve over these immense timescales. And what's really powerful here is how consistent all the data is. I mean, look at this table. It shows results from different studies spanning nearly 2 decades. And yeah, the exact numbers wiggle around a little bit as our methods get better, but they all converge on the exact same story. A cluster that's about 7 billion years old, located around 1,700 parsecs away, which is roughly 6,000 light years. This is exactly how scientific consensus gets built. And here's the part that really connects this distant, ancient cluster directly to us, right here. Our sun wasn't born alone. It was almost certainly born in a stellar nursery, an open cluster that probably looked a lot like a young Caldwell 1. But over billions of years, it drifted away from all of its siblings. So studying this cluster is a bit like looking back in time at the kind of family that our own solar system came from. So in the end, Caldwell 1 isn't just some anomaly that managed to survive, it's a time capsule. It's this unique laboratory for stellar evolution, a city of strange star systems, and a real glimpse into our own origins. Which leaves us with one final fascinating question. What else is hiding inside this ancient cluster, and what will it teach us next?